Okay, so we're gonna try this one more time. All right, so I was calculating the volume of this shape. So I have 1, 2, 3, 4 for my width. There were 2 rows. And then my third number is how many layers are there. And when I pull these apart, you can see that there are 2 layers. So when I do that, I have 4 times 2 times 2, which gives me 16 cubic centimeters. Now, what happens when I put my 2 shapes together as one? How would I find the volume for that? Well, I found the volume for this, that was 4, and I found the volume for this shape, which was 16. So now I can add those 2 together, and the volume for this structure is 20 cubic centimeters. So this is what we call additive volume, because we are adding the volume together to find the total volume of a structure. All right, so let's go ahead and look at our next problem. Uh-oh, give me just a minute here. Oh, here we go. Okay, so this time we're just given the structure and asked to find the volume. So from all of the work that we've done, we know that the volume is the width times the length times the height, or as I like to think of it, across the front, how many rows and how many layers. Okay, when I do that, I get 3 times 2 equals 6 meters, times 7 meters equals 42 cubic meters. So what if I had another rectangular prism that looked just like that? And I took that rectangular prism and I attached it to this one. So basically, it looked a lot like this. All right, and it was also 3 and 2 and 7. Okay? So how could I find the volume of these 2 structures once they're put together? Well, I could say that if the volume of this one is 42 cubic meters, the volume of this one would be 42 cubic meters, and I could add them together. And get 84 cubic meters. Or I could say that I have 2 prisms that are each 42 cubic meters, because multiplication is the same thing as repeated addition, and I would get 84 cubic meters. So it's just a matter of putting them together. Okay, so let's take a look here at number 3. Number 3 is the first one that we're going to look at that's a little bit different. It has the 2 different shapes, and as I mentioned earlier, these are a lot like a puzzle. And just like in a regular puzzle, sometimes you've got really big pieces and the puzzle goes together really easily, and sometimes you've got little pieces, and so it takes a lot of trial and error. These figures, these structures, oftentimes take some trial and error. And so the one thing that you can't do is just look at it and start multiplying and adding the numbers together. What you have to do is you have to first break apart each shape, because what you're about to find out is that sometimes these puzzles have missing pieces that you have to find and put together. Okay, so the first thing I'm going to do is I'm going to look at this box down here. Okay, so I'm looking for the measurement. So I see right away that my measurement across the front is 6 inches. I see right here that my length of this structure is 5 inches. Now, I come over here to the side and I notice right away that I have 2 different measurements. Since I have 2 different measurements in 2 different structures, I notice that there is a 4 here on this long side and a 2 here beside this shorter side. So the 4 goes with this side. So that's going to be my missing third number. So now I can find the volume of that bottom structure. And I get 6 times 5 is 30. 30 times 4 equals 120 cubic inches. And so now I have this shape here on top. Now, the shape on top doesn't necessarily use the same measurements. So I kind of have to look at what I have here. Now I already figured out that this part here, the 2 goes with that. I figured that out when I was doing the bottom one. So I know that one of my measurements is 2. The height is 2. This 3 here, the arrows are indicating to me that this 3 is the length of this section. So that means that if this entire structure, so let me bring out the physical here. If this entire structure was 6, like it is here, that this structure here is not going to be a total of 6. It's only going to be a part of 6. So when I look, it makes sense that that line would only be 3. So now I have 2 of my measurements, but I'm still missing a third. Can you see which of the measurements I'm missing? I have my width. I have my height. I'm missing this measurement here, which is my length. So what do you know about this structure that we talked about in the very beginning that's going to help us determine this length? All right, these are structures that are non-overlapping. That means they're all even. And in order for them to be even, that means that they have to be the same length. So if my diagram is telling me that this is 5, then because I know this is a non-overlapping structure, that means that this also has to be 5. And when I do that, I now have my 3 measurements, which I can put together. So it's 3 inches times 5 inches times 2 inches. I get 3 times 5 is 15. 15 times 2 is 30 cubic inches. All right, now, I'm not finished. This is 30 cubic inches. This is 120. So what would be the volume of this entire structure? All right, I take my 120 from my bottom structure and I add my top structure to it. And I end up with 150 cubic inches. So that would be my answer for this structure. All right, so let's take a look here at the next one. This one, you'll notice, has a lot more arrows. This one here had 1 arrow, but that taught us that wherever that arrow is, that's indicating that's the length of that segment there. So we've got a couple more arrows here. So first thing I'm going to do is I'm going to break them into my 2 different shapes. I like to color this top box yellow just to kind of give me the reminder that that's all separate. Okay, so I'm looking for my 3 measurements here for my bottom box. So I have that the length is 6 meters. I have over here that the height is 2 meters. And then here I have my length, which would also be 2 meters. So the volume for this bottom box is, or bottom rectangular prism is 6 times 2 is 12. 12 times 2 is 24 cubic meters. All right, so now I have to work on this top box. So the first thing that I'm going to do is I'm going to come up here to this arrow because that's really interesting to me. So when we did our last problem, the arrow gave us that section, and I talked about how it's just going to be a part of this longer piece, right? So now for the one that we're looking at this time, it doesn't give us that section, it gives us this section. So it's giving us part of the puzzle, but we have to figure out the missing piece. So if I'm looking at just a rectangle like this, okay? And if my bottom here is 6, then the property of a rectangle tells me that this side also has to be 6 because they have even sides. So if I'm looking at my paper and this line is 6, that means that this line is also 6. But I don't need to know the whole line. I just need to know this part right here. So here's 4. I've already used up 4. So I could think of it as like 4, 5, 6, our tape diagram, right? I've already used up 4. So how many more do I need to get to 6? I need 2. So that means that this line right here is going to be 2 meters. Okay? So I have my first measurement for this box, which is going to be 2 meters. Now, I'm going to use the same idea that I used in the last box, and because these are non-overlapping, since this edge is 2 meters, that means that this edge must also be 2 meters because they line up perfectly. So if this is 2, this has to be 2. If you need to build these structures, then feel free to get out your blocks and build. Just remember that that's not the most efficient way to solve these problems, that you want to be able to look at them visually. And if you know that it's going to take you a really long time to build those structures with blocks, then you may need to figure out how you're going to get the homework done at home, because it's probably going to take a lot of your class time if you try to build each of these structures. But do what you need to do. So I have this measurement, I have my width, and I have my length. Now I'm looking at my height. All right, so here's another piece of my puzzle. It's telling me that this whole section here, so like if I'm looking at this whole section is 4. But I don't want the whole section, I just want this. So there's no measurement here that tells me on this side what that little section is. So I'm going to have to go sneaking around. I'm going to have to look at the rest of the box. And if I look, and I'm looking just at my rectangle, this corner and this corner are going to have the same measurements. So if this side is a 2, that means that this side is a 2. And if the whole line is a 4, and I've used 2 of it down here on the bottom, that means that the height of this block must be 2 as well. So now I have my 3 measurements, 2 meters times 2 meters times 2 meters, which gives me 8 cubic meters. So I have found the volume of this box. I have this cube. I have found the volume of this rectangular prism. Now to find the volume of the whole structure, I have to add them together. So I get 24 cubic meters plus 8 cubic meters equals 32 cubic meters. And that would be the volume of that structure. As we're getting into these missing sides and having to use all the other information to help you solve it, please pause, use the power of pause, go back, rewind, look at it. Make sure you understand where these numbers are coming from. It cannot be an I don't get it. It needs to be a I've watched the video and I see where you're pulling these numbers from, or I don't understand how you're breaking that apart. So make sure your questions are very specific. All right, the last one that we're going to do tonight is a little bit more of a word problem. And it tells me 2 rectangular prisms have a combined volume of 135 cubic meters. So that means that if I have 2 rectangular prisms, the volume of this one and the volume of this one is going to equal 135 cubic meters. All right, prism A has double the volume of prism B. What is the volume of each prism? So for A, and I'm going to label it A, I basically have prism A and I have prism B. Now I'm drawing it like this because it told me that A is double B. And I know that it's going to take those 3 to equal 135 cubic meters. So over here, I have a total of 1, 2, 3 units. All right. Now, what I want to do is I want to find out how much 1 unit is. So I'm going to divide both sides by 3. Because when I do that, 3 divided by 3 will give me 1. And so 135 divided by 3, I'll go ahead and do my long division here. All right, I'm going to break this down for you. This is 100, okay? It's like if I had 100 block. If I have 100 block, I cannot make a group of 3 for that. So I'm going to take it and I'm going to bust it. 2, 3, 4, 5, 6, 7, 8, 9, 10 into 10 tens, because 10 times 10 is 100, so I've broken it up. I already had 3 tens. 1, 2, 3. Okay, so now I have a total of 13 tens. So I'm going to see how many groups of 3 can I make. I can make 1 group, 2 groups, 3 groups, 4 groups. And when I make those 4 groups, I use 3, 6, 9, 12 of the tens. I have 1 10 left over. I cannot make a group of 3, but I can still go smaller because it's a 10. So I'm going to take that 10 and I'm going to bust it into ones. 3, 4, 5, 6, 7, 8, 9, 10. All right, now I already had 5 ones, so I have to make sure that I get that in there too. 3, 4, 5. Now I'm going to make groups of 3. So altogether I have 15 ones. So 1, 2, 3, 4, 5. I get an even 45. I use all of my ones. I have nothing left over. So 1 unit is equal to 45 cubic meters. So what that means is volume or prism B is 45 cubic meters. And then prism A, which is double that or 2 times that, would be 90. And when I add them together, I get 135 so that I know that I'm correct. All right, so now I'm not done yet. That's just part A. Part B says if one face of prism A, so here's prism A face is that flat part, has an area of 10 square meters, what is the height? All right, so I have to use some schema here. So I'm gonna come, I ran out of room, so letter B here. And what I'm going to do is I'm going to kind of draw my prism, right? And I know that one of the faces has an area of 10. What is its height? Okay, so area is the length times the width. So the length times the width is 10, right? So what I need is the height. So if I know that 10 cubic meters times some number equals 90, because 90 is the volume of prism A, then I can go back and I can divide. So 10 and 10, that gets rid of that 10 here. 10 goes into 90 9 times. So 10 times 9 equals 90. So the volume, or the height of prism A is 9. All right, so these are going to take a lot of practice. They're going to take a lot of getting used to. This is really important because we will get into some where they don't line up, or there might be a little bit more shape involved. So you want to make sure that you get a good foundation on this and do your practice and do your Zern. I'm going to do a little bit of the problem set with you, just to kind of give you some something to work through as you're doing your homework. I'll do that in a separate video. Today in class, your job is to do the homework. You're going to do the same numbers of homework that I do in the video on the problem set so that you have that model. When you are finished, you will take your exit ticket and then you will go on Zern. Have a great day, and don't forget to watch the next video this evening.